Hi students, Professor Nugent here. Let's talk about two-stage least squares, an estimation method with instrumental variables in the case that we have multiple instruments for an endogenous variable. Recall that we're thinking about a model given by equation 1, where y1 equals beta naught plus beta 1 y2 plus beta 3 z1 plus u1, where y1 is the y1 is the dependent variable of interest, y2 is an endogenous explanatory variable, z1 is an exogenous explanatory variable, u1 is the error term. When we say that y2 is an endogenous explanatory variable, we mean that y2 is correlated with u1. We can use multiple instruments to help us get an unbiased estimate of beta 1 using the two-stage least squares method. The first stage is going to help us. We use the first stage to get the best instrumental variable, which is given by a linear combination of the instruments, the zj, that are most highly correlated with the endogenous explanatory variable y2. The best linear combination is given by the following. y2 is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus pi 3 z3 plus u2, where the expected value of u2 is equal to 0 and the covariance between zi and u2 is equal to 0 for I equals 1, 2, and 3. This equation is our first stage equation, and the best linear combination is given by y2 star, which is equal to pi naught plus pi 1 z1 plus pi 2 z2 plus pi 3 z3. Observe that these are our population parameters, and we have included the exogenous explanatory variables in the first stage of regression in addition to the two instruments. What we get from y2 then is the variation in y2 explained by the instruments and the exogenous explanatory variable that are by definition uncorrelated with this error term, with the error term in our structural equation up here. All right, our instruments, in order to be good instruments, they have to be uncorrelated with u1, as is the exogenous explanatory variable. So by definition, y2 star is uncorrelated with u1. Again, these are the population parameters. We can estimate this equation and get a y2 hat, which is equal to pi naught hat plus pi 1 hat z1 plus pi 2 hat z2 plus pi 3 hat z3. So again, when we estimate this linear combination is partialing out the part of y2 uncorrelated with the error term u1. y2 hat by way of the instruments and the exogenous explanatory variable. Okay, so we then leave aside the part of y2 that is correlated with the error term in u2. We leave that aside in the error in the first stage equation. Now, a T or an F test on the instruments in the first stage should always be completed. In this case, we have two instruments, so we're looking at the null hypothesis that pi2 equals pi3 equals 0, which is an F test. And to avoid weak instruments, a good rule of thumb is to use a critical value of 10. So reject the null hypothesis when your F statistic is greater than 10. And this helps us to avoid weak instruments. This is based on research from Stock and Yogo, 2005. We will talk more about weak instruments in a later video, but know that using a critical value of 10 helps us to avoid a situation where we have weak instruments and therefore potential bias in our estimate of beta 1. Stay tuned to the next video, and we will introduce the second stage part of two-stage least squares.